Hello there. Today we're going to discuss about the difference between scalar and vector quantities. Our objective for today is to know the difference between vectors and scalars. For you, what do you think about the vector? Vector means vector quantities has a magnitude or size and a direction. But what about scalar? Scalar quantities only have magnitude or size. When we say vector quantities, they have the magnitude and direction. It is important that the vector quantities have a direction. Example, say to the left, to the right, upward or downward. I will give an example. Here, this is the ground or a table. And I have a box. My objective is to move the box from here to there. Let's just say that when I move the box from here to there, the box traveled 5 meters. 5 meters. When we say 5 meters, what is this? Vector or scalar? 5 meters is a scalar quantity because it doesn't have a direction. I didn't state here that 5 meters to the left or to the right. It only has a magnitude or distance. A distance is also considered as a scalar quantity. But how about we will find the velocity let's find first the time. Let's just say that the box traveled from here to there at a span of let's just say 2 seconds. 2 seconds. We all know that with the time and distance, we can find the speed. The formula of speed is distance over time. This formula will answer our question: how fast does the box travel from here to there in a span of 2 seconds and with a distance of 5 meters? Speed is 5 divided by 2 is equals to 2.5. We can say that the speed is 2.5 meters per second. Now, speed is also a velocity. We can consider this 2.5 meters per second as the velocity of the box that traveled from here to there. This is our velocity. Now, if we say 2.5 meters per second or velocity, so this is a velocity, so can I ask you a question? So, velocity, is this considered as a scalar or a vector? So what? So let's just say that the information includes the box traveled from here to there. So the direction, I will give a direction. So example, the box traveled from here to there, so to the right. So if I add the velocity and the direction, so 2.5 meters per second to the right. So this. So can we consider this a vector or scalar? So because it has the direction or the information where the box traveled, so 2.5 meters per second to the right is also considered as a vector quantity because it has a magnitude or size and it has the direction. So another way of saying that this box traveled from here to there is what we call as a displacement. So displacement is a vector version of distance. So example, the box is displaced 5 meters per second to the right. So we can use the word displace instead of travel from here to there. So displacement is a vector version of the distance. So now, did you understand the difference between vector and scalar? So just remember that vector has the magnitude or size and direction. So it is important to include the direction. And scalar quantities includes magnitude or sizes. So examples of these are mass, temperature, and other things that is specified with numerical ways. So example like I have 5 bags like that, so it doesn't have the direction. So to know the difference between vectors and scalars, so I expect you to share this to your classmates or friends and share the information about the vector and scalar quantities. Thank you.
Good day, everyone. I am here to discuss about how to solve the vector resultant from the given vector. So we have the figure of what we have to solve. So first, we have to know about the sine function and the cosine function. So this is the sine function and the cosine function. The sine function is used for solving the y component and the cosine function is used for solving the x component. So sine function has the value of vy over vx and the cosine function has the value of vx over vy. For finding x, we have the given vy over r, and for y we have vx over r. So we will now start solving. So first, we have to identify what quadrant our figures have. So we have the quadrant 1, the quadrant 2, the quadrant 3, and the quadrant 4. Did you realize that each quadrant has the negative and the positive signs, right? So in quadrant 1, we have the positive y and the positive x. In quadrant 2, we have the negative x and positive y. in quadrant 3, we have the negative x and negative y. And finally, in quadrant 4, we have a positive x and a negative y. We have to remember it so that we can know our correct symbols for solving. So we will in quadrant 1, quadrant 2, and quadrant 3, we have the same solution. When finding the value for the x-axis, we have to use the cosine function, and we have to use the cosine function. So first, cosine function. So Vx1 is equal to the cosine function and the value of the angle times the distance. So there. So Vx so equals cosine function times we have an angle of 30 the angle of 30 degrees times the distance here is 12 meters. So 12 meters equals cosine times 30 times 12. So we have to use the calculator. So cosine times 30 times 12. Cosine 30. 12 times cosine 30. We have the value of 10.39. So we will include this in our table. So since we have in quadrant 1 we have a positive x and a negative y, we have to put a symbol positive, and then the answer is 10.39. So there we have the value for the Vx1. So for solving the Vy1, we have to use the sine function. So the sine function has So for solving Vy1, we have to use the sine function. Sine function times the value of the angle and then times the distance. So equals sine function, value of the angle is still 30 times the distance which is also 12 meters. Equals 12 times sine function times 30 is equal to 6. So in writing, we have to put their units. So in Vx1, since we have the unit of meters, we have to put meters. In Vy1, we have to use meters too. So in quadrant 1, we have positive. So positive 6 meters. So for solving quadrant 1, quadrant 2, and quadrant 3, we have the same solution as in quadrant 1. The only difference is how to solve in quadrant 4. So, just remember that in solving x, we have to use the cosine function, and for solving y, we have the cosine function. We have the sine function. So, thank you for listening, and may you learn something new.
So since we are done solving for the x and y of quadrants 1, 2, and 3, we will now proceed to quadrant 4. So you have probably noticed that there is no angle degree for quadrant 4. You can only see the numbers 2 and 6. So we will try to search for the degree of the angle. So we will be using tan, short for tangent. That is the most widely used. The formula is tan is equal to Vy over Vx. That is how you will find that is the equal for tan. So y is always the vertical part of the angle. So it is the number 6, and then 2 is x. So when looking for the angle, it will be y over x multiplied by tan negative 1. So let's try to solve that. So y over x, so 6 divided by 2 times tan negative 1. So the answer is the answer is 71.57. So that is the angle degree. 71.57 degrees. So since we already have the angle, let us now try to solve for the x and y. So the formula for x is y all over tan the angle, and for the formula for y is x multiplied by tan the angle. So since y is 6, so it will be 6 and then tan, and the angle degree is 71.37 degrees. So the answer is 1.99, but if we round it up, it will become 2. So that is our x. So for our y, the formula is y equals to x multiplied by tan and the angle. So since x is the number 2, it will become, and the angle. So if we solve that in the calculator, we will get the 6. So these are our x and y, 2 and 6. So thank you for listening, and I hope you understand the concept of time.
Hey there, fellow learners! I'm about to continue our topic today, which is vector. This will be our final topic, which is the vector resultant and how to solve it. Vector resultant. So in order to get the vector resultant, first, you have to get the summation of x. So we have there positive 10.39 meters, negative 3, by the way this is x, 3.88 meters, negative 16.97 meters, and 2. And also, you need also the summation of y. So we have there positive 6 meters, positive 14.49 meters, negative 16.97, and negative 6. So, we're gonna solve it using a calculator. We have negative 2.48. So, now that we have the summation, we can now solve the vector resultant using the formula. Oh wait, I'll just put it here. So now, we can now solve for the vector resultant, for we now have the summation of x and y using the formula Vx is equal to the square root of the summation of dx squared plus the summation of dy squared. So we'll now substitute. We have here the summation of we have the summation of x, which is negative 8.46 squared plus negative 2.48 squared. So we're gonna use a calculator. So negative 8.46 squared is equal to 71.57. Now to get the square root of the summation of y. Which is equal to 6.15. Now we're going to get this sum, which is 77.72. Lastly, we're going to get the square root of this, and it will give you 8.82. This now is our vector resultant. So that's it. That ends our topic about vector. Hope you learned something. See you again.
The motion of objects is an obvious part of our everyday life. It was not until the 16th and 17th century that our modern understanding about motion was established. The study of motion, the motion of object, and the other related concepts about force and energy is called mechanics. Mechanics is divided into two parts. The kinematics and dynamics. Kinematics is the description of how objects move, while dynamics deals with force and why objects move as they do. So in this chapter, we will discuss about speed, velocity, and acceleration. Speed is defined as the distance traveled in unit time. So speed can be derived from the formula speed equals to distance over time. So to understand about this equation, we can use this table, or this table can help us to know the formula of the speed. So for example, when we look for the equation for the speed, we just need to cover the speed, and then we can find that distance is over time. So this is how we derive the formula of speed. So when the situation looks for the distance, the equation will be distance is equals to speed times time. And when we look for time, the equation will be distance over speed. So speed talks about the movement of an object. So while velocity talks about the direction and the magnitude of how the object moves. Our next topic will be about velocity.
Velocity and speed are both similar, but the difference is velocity is speed with direction. So velocity is a vector quantity, and while speed is only a speed. So that's the difference of velocity and speed. And velocity in 5 meter per second. Example of a velocity going to north west is different to 5 meter per second going to northeast.
So our next topic for today is acceleration. So let's say if you are traveling in your car at 50 kilometers per hour, and then suddenly after a few seconds it becomes 70 kilometers per hour, and the car is accelerating. If the car is slowing down, it is called negative acceleration or deceleration. But for now, let us just the sudden change or the sudden change of the speed or velocity of a moving object is acceleration. So the formula for velocity is A is equal to the final velocity minus the initial velocity all over time. So to put this formula into use, we have a word problem right here. So let's say calculate the acceleration of a car that travels from rest to 28 meters per second in 10 seconds. So we just have to A is equal to final velocity is 28 meters per second minus 0 since the car was at rest before it started to move at 28 meters per second. All over, the time is in 10 seconds. So A is equal to 28 is 2.8 meters per second squared. So this is how you normally do it, but when there is a slight difference between your final your number of how do you say this velocity and the time given, like for example if your velocity is in kilometers per hour and your time is in seconds. I have a new set of problems here. Like a car accelerates along a straight road from rest to 75 kilometers per second hour in 5.0 seconds. What is the magnitude of its average acceleration? So I have made here the formula for the formula we use first. So A is equal to 75 kilometers per hour minus 0 kilometers per hour all over 5.0 seconds. This means that there is 15 kilometers per hour per second. So on average, this means that in every second there is a 15 kilometer per hour increase on the car's velocity. And so in 2 seconds, the car's velocity may have increased to 30 kilometers per hour. So we note that we have two different But there are two different units of time, and normally we usually go with meters per second. So to change 75 kilometers per hour into meters per second is and that leaves us with 75 multiplied by 1,000 all over 3,600, which is equal to 21 meters per second. The next thing we do is to replace 75 kilometers per hour and 0 kilometers per hour into 21 meters per second and 0.0 meters per second. All over 5.0 seconds. A is equal to 4.2. So the answer is 4.2 meters per second over second. So this is also equal to 4.2 ms squared. So that is how you do it.
So now, if we are going to find the time, speed, or the distance of an object, one way is to use graphs. So if we are going to find the speed, we can use distance time graphs. So we all know that speed is equal to distance over time. So this is how distance time graphs looks like. So one example is this graph. So we take 5 kilometers as distance and 1 hour for time. So speed is equals to distance over time. Speed is equals to 5 kilometers over 1 hour. Then the answer is speed is equals to 5 kilometers per hour. So now, if we are going to find speed, we must use the distance time graphs. So by the way, this is how distance time graphs look like. So we all know that the equation for finding speed is equal to distance over time. So example is this graph. So we take 5 kilometers as the distance and 1 hour as the time. Speed is equals to distance over time, and speed is equals to 5 kilometers over 1 hour. So the answer is speed is equals to 5 kilometers per hour. So for finding the distance, we can use the speed time graphs. So this figure here shows how a moving object moves at a constant speed. So the formula for finding the distance of a moving object moving at a constant speed is equal to speed times time. But in here, we are not talking about constant speed. We are talking about acceleration. So we must cut this figure in half. So to make it a table or a figure of acceleration. So that makes the equation distance is equal to 1/2 speed times time.
To prove that his theory is is true, here's a demonstration on the falling object. So here's a paper and a pentel pen. So I will fold it and yan. And here. The paper and the paper has a high air resistance because the paper is flat and here. But if you crumble the paper and do it again, and they fall at the same time in the ground. So the crumpled paper has a low air resistance like the pentel pen, so the air doesn't bother. So here's a word problems about falling objects. Suppose that a ball is dropped from a tower 70 meters high. How far will the ball have fallen after a time? Time 1 equals 1 second. Time 2 equals 2 seconds. Time 3 equals 3 seconds. Now the acceleration due to gravity equals 9.8 meter per second squared. So here's the formula on how to find the displacement or the distance that target. So displacement 1 equals 1/2 acceleration due to gravity times time squared. So substitute 1/2 9.8 meters squared 1 second squared. So the answer is 4.9 meters. Then the displacement 2 equals.
So with these scores, we can't just compare a certain score with another score in the same unit. We can also compare a score from a different unit to another. So, for example, if you have a score of 85 in a beauty contest compared to a 100 in an IQ contest, an IQ test.
For the examples about the z-scores, applying the formula for z-score to a score of y is equal to 85, and coming from the sample of mean, which is my equals 75, and the standard deviation sy equals 17, gives us the equation z is equal to y minus my over sy is equal to 85 minus 75 over 17, which is 10 over 17, and the final answer is 0.59. And this is the given example how to get the z-scores, and in the definition you learned about the y, which is the regular.
Good day to each and everyone. I'm here to discuss about how to use the C-table. So, alright, suppose your problem is you'll get the probability of students whose IQ is between 85 to 115. So the given standard deviation is 15. Since you are knowledgeable of solving for the z-score, so I assume you already know how to solve this. So if you try to solve this problem, you'd get -1 for 85 as the sample score, and a +1 for the 115 sample score. So this point already we'll be using the z-table. So here's how to use the z-table. Alright, so you use the z-table to find the p-value. So when you solve for the z-score, it came out that your z-score is 1. So you'll find here in the z-table that you first look at the first column, which is the ones digit and the first decimal digit. So it's 1, so it's 1.00. So you'll find out here the first column 1.0. Then you look for the second decimal digit, so 0. So you just have to intersect the.
Good day. So today we will tackle about another kind of statistical testing, which is chi-square. So unlike other statistical inference, this chi-square test does not only focus on the mean and the proportion and the standard deviation itself, but it also focuses on the whole distribution of the population. So the chi-square test it examines the whole distribution and the relationship of the two variables. So what we have here is the two types of chi-square test, which is the goodness of fit and the chi-square test for independence of two variables. First, let's start to have an overview for the goodness of fit. So when we say the goodness of fit, it is a statement or claim that is concerning on the nature of the distribution of the whole population. So now let's move on. Let's now move on to the chi-square test for independence of two variables. So in chi-square, if we have encountered this set of words, it means that this lets us know if the two variables we are testing are independent or dependent on each other. So this also lets us know if the two variables have a relationship between them. So all in all, chi-square is the most useful and the most widely used tool in statistical work. So let's just put an example on the performance of the students. So the chi-square test lets us know if it lets us know if we will accept our hypothesis or we will reject our hypothesis and accept the observed one. So we have here the chi-square formula. So the term chi-square is used the term chi-square is used because of the Greek letter x, which is used to describe the distribution in this test. So it can also be seen in all the elements in this distribution that they are all squared. So the symbol x squared is used to denote the distribution. So when we say x squared, that is the chi-square. So the formula for chi-square is O minus E squared all over E, wherein O is the observed data and E is the expected data. So to learn more about all of this, my partners will share with you on the do's and don'ts in the chi-square test.
So, good morning everyone. So, our topic is all about the chi-square test for dependence of two attributes or variables. So suppose that an observation is classified and
classified into two characteristics, say A and B. So we can test those characteristics if they are independent or dependent, or they are related to each other. So in this case, we can use this chi-square test for independence of two attributes or variables. So this is how to do this test. So first, this is the data. This is the data. So this is the observed data. So the observed data is the one that is the data you have gathered from interviewing the respondents. So while the expected data are the data that is expected. So that's all.
So for the expected data, all you need to do is 70 times 35 divided by 100, so you will get 24.5. And then 70 times 30 times 35 divided by 100 equals 10.5, so on and so forth. And if you add this 24.5 plus 10.5 equals 35, and then 24.5 times plus 35 plus 10.5, you will get 70.
So
And then proceed to the next.
So this is the distribution table of the chi-square test. So this O means the observed data, E means the expected. So this is the difference between the observed and the expected, so on and so forth. So first, we will fill up the observed. We will fill up this observed. So here are the data. Then the expected. After that, we subtract these two to get this. And after that, you squared this the difference between the observed and the expected. Then after that, you divide the answer with the expected one. So after that, you will add this, then you will get this. So this is the chi-square, which is 0.1133. So after that, we will get the degree of freedom. So in order to get the degree of freedom, you will get the number of rows minus 1 times the number of column minus 1. So in this case, we have 2 rows. So 2 minus 1 times in this case we have 3 columns, so 3 minus 1. So the answer, our degree of freedom now is 2. So after that, we will consult to our the chi-square distribution table, the table. So after that, we will find, here we have the degree of freedom. Then in the upper side there is a margin of error. So the most commonly used margin of error is
0.5.
0.05, which is 5% margin of error. So here we have 5.991. So this is our reference now. So as we can see, our chi-square is less than this one. So now we can accept the null hypothesis. So null hypothesis means that the two variables have no difference. So thank you for listening, and that's all.